All right. A couple of housekeeping things before we start looking at section 2.1 today. Your first exam is due this Friday, by this Friday. You have any time between now and Friday when the testing center is open to take the exam. So you want to be sure that you carve out 17 minutes of your time. The time limit on the exam is 70 minutes, a class period, basically. Have any of you taken it yet? How was the testing? How was the testing center experience? Fine.
It's fine, they seem confused at first, but
Really?
yeah, like, when I first went in there, they like didn't know what I was talking about.
You just say like you're here to take the test.
Yeah, you say I'm here to take Professor Castle's functions and modeling test. And they should be able to figure it out.
They did, it was just confusing.
It took them a second to think it over. So Professor Castle's functions and modeling exam 1 is what you're taking. All right, that's about all I want to say about that. If your My Math Lab, if temporary access has expired, you need to take care of that right away. I have to say, hands down, your class wins the prize. I don't know what I should do, bring you donuts or something. I only have 3 of you that have not got your permanent access. Now you think, oh, 3 of us haven't done it. Hands down, the best percentage of any class ever. Every other class I struggle, would you believe, till mid-semester frequently to get people to get their access. And then what happens? You're 4 or 5 weeks behind. So don't do that. Get your access as soon as possible. All right. Any questions? We are going to start 2.1. I know exam 1 is still lingering, haunting you. We are going to start chapter 2. I did notice that I had an issue with the schedule that I'm going to fix. I had actually scheduled 2 sections in one day next week. I think we can push that out to 1 section a day. I don't think we'll have any problem doing that. So I will do that in your schedule and repost it. All right, so we are going to start looking at chapter 2. It's out of my way. I have a problem with recording this via Zoom. This is the only thing that's in my way. All right, so we are going to start chapter 2 today. Maybe, maybe not. There we go. So first section we're going to cover today, we are going to look at solving equations, both algebraically, and then we're going to break out those calculators and do it on the calculator graphically, and it's very cool. In section 2.2 on Monday, we're going to fit lines to data points. So we're going to take a set of data. We are going to create a scatter plot. And then we're going to find the line that fits that data the best. Your calculator can do that with a couple of keystrokes. And then in section 2.3, we'll solve systems of linear equations and variables. And then we'll look at linear inequalities. In section 2.1, we're going to first solve equations algebraically, which is the way that we are used to solving equations. Then we'll look at a couple of real world applications. And that is the nice thing about this course, is that it does have a lot of real life applications to it. Unlike college algebra, I told the 9:30 class, these sections in college algebra are word problems. And all the sections of college algebra, and life is a word problem, it just is. Then we'll look at comparing the solutions of equations with zeros and x-intercepts. And they're all the same thing, which is kind of cool, because once you find one, you found the others. And then we'll solve linear equations graphically using our calculators. We're going to graph them and first look at the x-intercept to find the solution. And then we'll graph both sides of the equation and find the intersection of those two lines to find the solution. And then we'll solve, they call them literal equations, I call them formulas. The nice thing about the world is so much of it has been modeled for us using formulas. Isn't that nice? Yes, it is. But can we take a particular formula and solve it for a particular variable? And the answer is, of course, we can. Because again, variables are letter representations of numbers. They are just numbers. So if I can divide both sides of an equation by 2, can I divide both sides of an equation by A? Sure. Why not? And then we'll look at direct variation, which I use all the dadgum time in knitting, because I am a knitter. And to find gauge, because if you're knitting a sweater, is it important that you're knitting to the gauge that the person who wrote the pattern knitted to? Maybe. Otherwise, your sweater will not be the correct size. So you have to be careful with that. All right. So linear equations, there are 2 forms of a linear equation. The first form is in one variable. A linear equation in one variable has one variable, and we call it x. A and B are letter representations of constants. So A and B are constants, x is the thing that varies. An equation in 2 variables, you add a y to it. So an equation in 2 variables has that form ax plus by equals c. A, b, and c are constants. X and y are the things that vary. So I could write a couple of equations in 1 variable and 2 variables. So this would be an equation in 1 variable for x plus 15 equals 27. You only have 1 variable there, everything else is constants. Or I could write in 2 variables, 3x plus 2y equals 6. In the first case, there is a value of x that can satisfy this. There is a solution x equals. In the second equation, the solution takes the form of an ordered pair. There's an x and a y that satisfy that particular equation. As a matter of fact, in this case, there are an infinite number of x's and y's that will satisfy that equation, because that is the equation of a line. And when you graph it on the coordinate system, you get a line. You get a line that does this. And there are an infinite number of ordered pairs on that graph, correct? That would satisfy that. All right. How do you solve? First, let's look at equations in 1 variable. How do you solve equations in 1 variable to get the value of x that satisfies that? What value of x satisfies that? 3, I think. Well, you have rules. These are the steps that you can use to solve equations in 1 variable. If a linear equation contains fractions, then it's probably a good idea to get rid of them, because we don't like adding and subtracting and multiplying and dividing fractions. That's just something that you're not real fond of, and it's just a place to make a boo-boo, so we get rid of them. we multiply both sides of the equation by a number that will remove all denominators from the equation. If there are two or more fractions, use the least common denominator of all the fractions. Typically, you can just look at the fractions and determine the least common denominator. They don't do anything really tricky here. It's the smallest multiple that all your denominators will divide into. Perform any multiplications or divisions to remove any parentheses or any other symbols of grouping. Perform any additions or subtractions to get all the terms containing the variable on one side and all the other terms on the other side of the equation. Combine like terms. Actually, I would combine like terms first, then make sure that I move the x's to one side and the constants to the other. Then divide both sides of the equation by the coefficient on your variable. That will isolate your variable. And you should always check your solutions, which is something that I get very lazy about doing once I start solving these in class. You should check. I just get lazy because of time. I have a time constraint. I've got an hour and 15 minutes to get all this done. So I usually, that's the part that gets sacrificed, is the checking. All right, so how do you solve this particular equation? It is an equation that contains fractions because I have numbers in the denominator. So the book recommends, and so do I, to get rid of the fractions. So how do you get rid of the fractions in an equation? You multiply both sides of the equation by the least common denominator. And let's think about this. The least common denominator is the number, the smallest number, that all your denominators will divide into. It's the least common multiple of all your denominators. So your denominator will divide into this number you're multiplying by. That's by definition. So what happens if you multiply by a number and you can divide the denominator into it? What happens to your denominator? Bye. Is that a good thing? Yes. Okay, so looking at the 4 and the 3, can you just look at that and tell me what the least common denominator is?
3.
Not 3, you said 12. It's 12. Why is it 12?
Both go into.
4 will go into 12 and 3 will go into 12. Is it the smallest number that both 4 and 3 will divide into? It's also the common denominator. What's a common denominator? If you just take the denominators and you multiply them together, that's the common denominator. So least common denominator is the smallest number they will divide into. The common denominator, you just multiply them all together. And in this particular case, they're the same thing. So I am going to multiply both sides of this equation. By 12. And that will get rid of my denominator, right? Because the 4 on the left-hand side, will the 4 divide into the 12? On the right-hand side, will the 3 divide into 12? Okay, so let's divide by 12. Divide by 12, multiply by 12. Now, if you have multiple terms on one side of the equation or the other, just multiply each term by that LCD. So I'm going to multiply the x over 3 by 12, and I'm going to multiply the 1 times the 12. So I multiply every term on the right-hand side by that number 12. Okay, so what happens? Will 4 go into 12? How many times? 3 times? So what do you end up with? You end up with 3 times what? 2x minus 3, because the 4 divides into 12. So you end up with 3 times 2x minus 3. Okay, how about on the right-hand side? Will 3 divide into 12? Will it divide into 12 4 times? So what do you end up with? 4 times x. And then 12 times 1. Now what? Got rid of the fractions. Do those parentheses. Yes, if I have parentheses on one side of the equation or the other, I do need to get rid of those. How do I get rid of my parentheses? Multiply. So what am I going to multiply? I'm going to multiply the 3 times the 2x, correct? What's 3 times 2? Is that 6? And then I'm going to multiply what? The 3 times the minus 3? What's 3 times minus 3? Minus 9? Then what? The other side. See, you're adding 9 first. I would add the x's first, but that's fine. We can add 9 to both sides. We can do that, sure. What happens if I add 9 to both sides? I typically do the variables first so I can control the sign of my coefficient. That's just Lisa. Okay, so what do we get?
X equals 1.5.
21? Then what? Do what?
Right?
2x, so you're subtracting the 4x from both sides? What's that?
It's 10.5, not 11.
It's okay. Did I do that right? It's weird. Oh, that's right. You could write it as 10.5, just be sure that you look in the instructions in my math lab. If it tells you to simplify your fraction, do you want to leave it like this? You should do. Okay, if they tell you to write it as a decimal, round it off, are you going to write it as a decimal? So just be sure you read the instructions. Your calculator will simplify fractions. It will do that. All you have to do is do alpha y equals number 1, get to your fraction, put your numerator in there, your denominator in there. If it can be simplified, it will simplify it. But it will say something like simplify the fraction if it wants you to leave it as a fraction. So we're going to leave it like this. Although that is 10.5. That is what that is equal to. Okay, well, that was fun. Want to do another one? You don't look near as enthused as I am. More fractions. You're welcome. What would you do? Anybody wanna? Venture a guess?
10.
Hmm?
10.
10? Got the answer?
Oh, I didn't see the 720.
By like 10 over 1 or 10 over 1?
Well, I multiply the -0.5 and the y/2 first. And that would help me decide what my LCD is. So because I have a multiplication of fractions here, I'm gonna go ahead and do that first. And that'll help me when I multiply by the LCD. That's, in my opinion, that's what I would do. And since I'm doing it, my opinion counts. So it's gonna be y/5 minus, how do you multiply fractions? It's the easiest thing you can do. You multiply the numerators, y times 1 is y, 2 times 2 is 4. Multiply numerators, multiply denominators. So is that y/4? It looks a little bit better. Now you said 10 or 20. Why is it 20?
Because, well, now that's what they would both go into anyway, and if you multiply them together, that's what you get.
So it is the least common denominator, 5, 4, and 20. What's the smallest number that 4, 5, and 20 will divide into? Well, that would be 20. So we're gonna multiply everything by 20. So over here on the left-hand side, I'm gonna multiply the first fraction by 20. Minus, got a minus here, right? Minus, minus. Second fraction by 20. And on the right-hand side. And what happens? Will 5 go into 20 4 times? So do you end up with 4 times y? Minus? Will 4 go into 25 times? So do I end up with 5 times y? 20 divided by 20 is 1. So 20 over 1 times 7 over 20 is 7.
Is it just always gonna be the opposite? For the things that when you're manufacturing,
I mean the opposite.
because the y over 4 turns into 5 times y, and the y over 5 is turned into 4 times y.
Only in this instance will it do that. If there was other numbers, it may or may not do that. It may or may not. In this case, since 4 and 5 have no common factors, then the LCD is 4 times 5. That's how you know that the LCD is just their product. They have no common factors. So in this case, it will work. Okay, now what?
Do the 4y minus 5y.
What's 4y minus 5y?
Negative 1.
Negative y? Are you done?
So.
Who said no? What's that? You need to divide by a negative. If there's anything in front of your variable besides the number 1, you have to divide by it. So what is that number in front of the y? Negative 1. So do I need to divide by negative 1? Yes. What's 7 divided by negative 1? That happens a lot, where you forget that you have to divide by that negative 1 at the end. But if there's anything in front of that variable besides the number 1, gotta take care of that. Okay, having fun yet? I am. Do you have a calculator that can subtract, add, multiply, and divide decimals? Why, yes, you do. So do I care that this has decimals? Look, it says solve for x if y equals 0.72. So what are you gonna do? Are you gonna plug that in right there? So you're gonna get equation in one variable. If they tell you y is a constant 0.72, can you plug that into the second equation and get an equation one variable x? Sure. So what do we have? What do you want to do?
-115 over 8.
You got it a little big. Let's step through and see what we get.
Add 2.56.
Why are you adding 2.56 both sides?
Oh,
Get the x.
that's right.
Yep. Isolate the term that contains the x. We need to get rid of the 2.56, so we're gonna add it to both sides. Do you have a calculator that can add 0.72 and 2.56. What is that? 3.28. Now what?
By 1.3.
So do you have a calculator that can divide 3.28 by 1.312? Why, yes, you do. What do you get?
2.5.
2.5, 2.5. And would we leave this written as a decimal? Yes. Why? Why would you know that you can just leave that as a decimal?
Because the rest of them are.
Because the rest of them are decimals. If you started with decimals, your answer is going to be in decimals. If you start in fractions, typically your answer will be written as fractions. For applied problems, you must remember to include units of measure with your answer and make sure your answer makes sense. So my example of giving an exam where I caught two students with a little bit of academic dishonesty. You're rowing a boat up a river. The current of the river is flowing at 5 miles per hour. The speed that you're rowing is at 2 miles per hour. And they circled that answer and went on their merry way. What's wrong with your answer? If the current of the river is 5 miles an hour and you're rowing upstream at 2 miles an hour, where are you going? Downstream. Because the net would be 3 miles per hour in the wrong direction. So stop and make sure your answer makes sense. If you're solving for time and you get a negative, that doesn't make sense. So just stop and think, does that make sense, John? Okay? Okie dokie. It's hard for some people to pay off credit card debt. It's hard for everybody to pay off credit card debt in a reasonable period of time because of high interest rates. That's how they get you. Not to editorialize, but credit cards are a loan. That is what they are. When you buy something using a credit card, you are borrowing money to buy that. And you're borrowing it at an exorbitant interest rate. It's right, it is a loan. The interest paid on a $10,000 debt over 3 years is approximated by this equation. Y equals 175.393x minus 116.287, and the units of that equation are in dollars. When the interest rate is X%, so X is an interest rate on your card. What is the interest rate if the interest is $1,637.60? So the interest paid is Y. And it's modeled by this equation where X is the interest rate. So if they tell you how much interest you are paying, can you figure out what your rate is? The answer is yes. So you're going to make that substitution for Y and then solve this equation for X. So what do we have? 1637.6. So we're going to substitute 1637.6 for our Y in our equation. Okay, now what are you going to do? Add the 116. You have a calculator that'll do this, right? My calculator told me, because I certainly didn't do that in my head. This is 1753.887. Now what? I should stand on this side of the room, make you guys in. Now what?
175.
Divide by 175.393. Isolate the x. What do you get? So 9.9997. So rounding off. Round that off to the nearest ones. Yeah. So x is approximately 10. And what are the units on this? Percent. This is a percentage rate. This is what rate you're paying on your card. That sounds really low to me, by the way. They're usually up in the 20-something% range. And the other problem, I used to teach, when we had QR in the classroom, I teach QR. We talk about how they charge you. Every time you put a new balance on your card, they charge you then interest. It gets ugly real quick. So approximately 10%, and the squiggly equals means approximately. And since they told me to round it off to the nearest ones digit, I did the round off there. Okay. For a period of time, a man is very successful speculating on an internet stock, with its value growing to $100,000. Man, I think I'd take my money out at that point, but no. The stock drops rapidly until its value has been reduced by 40%. What percent increase will have to occur before the latest value returns to $100,000? So you got a two-part question. The first part of the question, he has $100,000 worth of stock that drops in value by 40%. What does that mean? It's $60,000 now. How does she know it's $60,000? What's 40% of $100,000? 40,000, exactly. You never can do a calculation in mathematics using the percent symbol. The percent symbol means, it definitely means, it's by definition not part of 100. That's what it is. So the percent symbol means 0.01. That's what it means. So 40% is 0.4. 0.4 of 100,000 is 40,000. So since his stock has been reduced by 40,000 bucks, it's now worth $60,000. And you probably already knew that before I went through this long explanation. You have $100,000 worth of stock and it's reduced by 40%. What have you got left over? 60%. What's 60% of 100,000? $60,000. So he now has 60 grand in stock. Now, what he wants to know is, what percent increase do I have to get this back to $100,000? Tricky. So how do you find the percent increase of the 60 grand? Do you multiply it by its interest rate? So let's say you have a 2% interest on the 60 grand. So is that 0.02 times 60,000? So how do you find the percent increase? Do you multiply the percentage rate by your amount of money? So the amount we have, which is $60,000, plus the increase, which is going to be our interest rate times how much money we have. We're gonna have that equal to, we want to get it back to $100,000. So how much money do I have? I have $60,000. What's my increase going to be? Well, whatever my rate is times $60,000. Whatever that rate is times $60,000, that will be the increase. So I'm gonna write that as X times 60,000. So X is going to be my interest rate. And that's gonna be equal to $100,000. So I have to take that original amount, add whatever interest I'm gonna earn, interest rate times my investment, and that's gonna equal the amount I want. So what do we do? Subtract 60,000. Divide by 60,000. So what's 40,000 divided by 60,000? Is that 0.666666? Or 2/3? Okay, so let's discuss. That is an interest rate in decimals. Typically, when we write interest, we write it as percentage. So how do you convert a fraction to a percentage? You multiply it by 100. So if you have a fraction and you want to write it as a percent, you multiply it by 100. That's what you do. If you have a percent and you want to write it as a fraction, you divide by 100. If you have a fraction, you want to write it as a percent, you multiply by 100. So however you want to do this, it's 200 over 3 is what it is. Now, how do you write that? Well, it depends on what my math lab wants. So it's 200 over 3. Which is 66 2/3. Or 66.667. Or 66.7. Or 67, depending on how they want it written. But can your calculator write 200 over 3 as a mixed fraction? Yes, you can do that. So, open the calculator.
Interest rate, are we always gonna want to round it to just the 2 then? We don't wanna have a point?
It depends on what they ask you in my math fraction. I would round that if it were me, I'd round that to 66.67%, which is huge. Do you know any investments that return 66.67%? We're all shaking our head now. No, it's not gonna happen for him, is it? So, because he lost so much money, that's why I said I would have pulled it when it reached 100 grand, I would pull that. I'm chicken, stop. For years and years and years, I kept all my 401k in money market. I did not put it in stocks, it was all in money market accounts and stuff. And I made money like a gangbuster. When I pulled that money out of my 401k and put it into a different, an IRA account where they're investing in stocks, I lost money the first year. I should have just left it alone. But what are you gonna do? Okay, so what do we have? 200 divided by 3? So we can change that to a fraction. It might not, what can we do? Will it do it to a mixed fraction? Maybe not. Yeah, it goes back to 200 over 3. I would have to do that 0.66666. So take that fraction of my fraction. I know it's got 66 whole parts and 0.6666 fractional parts. Take that, put a whole bunch of them in there. And tell my calculator to change that to a fraction. So you can do it that way. That's probably the easiest way to do it. You got 66 whole parts. And then what have you got left over? That decimal 0.666666. Change that to a fraction, so you got 60 and 2/3. So if that's the way they want you to write it as a mixed number, you can do it that way. All right. The zero of a function. Kind of segue into a new topic. But this leads us to a graphical method of solving equations. Any number for which f of a equals 0 is called a zero of the function f of x. So a is a 0 if, when you plug it into the function, you get an output of 0. So the input a is a 0 if, when you input it, your output is 0. So for whatever x that is, if y is 0, that's a 0 by definition. So here are these following concepts are all numerically the same. The x-intercepts of the graph of y equals f of x is a 0 of the function. So if your function crosses the x-intercept, the x-axis, it has an x-intercept, that's a real number, that is a 0 of your function. So if you plug that number a into the function and your output y is 0, where is y equal to 0? On the x-axis. So is that number a an x-intercept? Yes. If it's an x-intercept, it is a real 0 of that function, and it is the solution to the equation f of x equals 0. They all mean the same thing. So if you have a number a, you can plug into a function and get 0 as an output. That is an x-intercept, a real 0, and it's the solution to the equation f of x equals 0. All the same thing. So when you solve these in your homework, and there's a zillion of them, if you find one answer, can you just plug it in for the rest? Saying. Okay, f of x equals 13, x minus 39. What is that function equal to if you evaluate it at x equals 3? What's f of 3? What's 13 times 3 minus 39? 0. So what's the 0 of that function?
Yeah. Or the y.
Oh. The 0 is the number when you plugged it into that function, you got an output of 0.
Oh, 3.
The 0 is 3. So what's the x-intercept? 3. What's the solution to this equation? 13x minus 39 equals 0. 3. If you evaluate that function at a number and you get 0, if you evaluate the function at a number and you get 0, that is a 0 of that function. It is also an x-intercept. It is also the solution to the equation. Take that function and set it equal to 0. All mean the same thing. Okay, so we can use this to solve linear equations algebraically. Let me show you how to do that. First of all, rewrite the equation you are trying to solve with 0 and nothing else on one side of the equation. Then enter the non-zero side of the equation found in the previous step in the equation editor in the y equals of your graphing utility and graph the line with an appropriate viewing window. Be certain that you can see the line cross the horizontal axis. If you can't see it cross, you need to adjust your window. Because this isn't going to work unless you can see it. Find the x-intercept by using the 0 command after Pressing second trace. You can find the zero, the x-intercept of this function using the zero command. The x-intercept is the value of x that makes the equation equal to zero, so it is the solution of that equation. The value of x displayed by this method is sometimes a decimal approximation of the exact solution rather than the exact solution, but you can change it to a fraction using math 1. I'll show you how to do that. It's very slick. Okay. Very slick. And I've been using this method personally forever, especially in calculus. When you got these really ugly equations you have to solve. And you think, I don't want to do that. Okay. I think I'll let my calculator do it. All right. You remember this one? Okay, let's solve that using our calculators, using a graphical method. Okay, so the first thing you want to do is get zero on the right-hand side of the equation and everything else on the left. So I'm going to take this and I'm going to move it over here by subtracting it. And I'm going to take the +1 and move it over here by subtracting it. Okay, so I just moved the x over 3 over to the left-hand side. I moved the 1 over to the left-hand side by subtracting. All right, so now I'm going to take the left-hand side of that equation and I'm going to put it in my calculator in the y equals. I'm going to graph it. Okay, so let me find my calculator. Okay, so I'm going to go to my y equals. And I'm going to type this in and I'm going to use my fraction key on my calculator because it just makes life easier. So I'm going to go alpha y equals number 1. Oops, helps if you push the right button. And what did I have? 2x minus 3 over 4. Is that the first term? 2x minus 3 over 4. Then I'm going to move out of that fraction. And what am I subtracting? Am I subtracting x over 3 minus alpha y equals number 1 x over 3. And I'm going to arrow out. And then what are we doing? Subtracting 1. That look good? I have no idea what the window on this calculator is because we've been playing with it. So I'm going to do a zoom standard, zoom 6 to get back to that standard window. I happen to know what the answer to this question is because we've already done it. It's over there. It's actually outside the window. It looks like you can see it, but you really can't. It's over there like 1/2 a tick over to the right of my tens unit because it's 10.5. Isn't that what the answer is? Okay, now how do I determine what the answer is? Well, you can use the 0. So above the trace is your calculate menu. You see that? We're going to go second trace. And number 2 is 0. A 0 and an x-intercept and the solution to this equation are all the same thing. So I'm going to hit 0. And it simply asks me for a left bound. So I need to be to the left of that 0. That 0 is right in there somewhere. So that's fine. And then I have to turn my trace on and move over to the right. And I'm going to keep moving until I really truly get to the right of it. And it has a problem. You see what its problem is? You see that? What's its problem? The window's not big enough. So since the cursor will not move any further, I'm not to the right of that. The window is not big enough, so what I'm gonna do, I'm just go over here and change my max to 15, I don't know, something. Graph it again. Did I get it changed? I like that, I'm gonna change it maybe to 20. I want to be able to see that. Why is it not changing my window, folks? Is your window changing? Is it just me? Your window's changing? Do you think there's something wrong with my calculator? Okay. Reset my calculator. Yeah, I'm gonna go my y equals. Type this in again. This is like turning your computer off and on again. Which cures many an ill. Do you know turning your computer off and on again can even cure strange things going on with your browser? Oops. Hit the wrong button. X. Number 3. Oh, I did it again. Like a dope. -1. Does that look good? And let me, on my window, let's just go set my window right away. That's better. I don't know what was going on. Who knows? But going to your second memory and resetting your calculator can cure a lot of ills going on with your calculator. Okay, so now I'm going to go to my trace, my calculate menu above my trace, and calculate that 0. So is that to the left? Sure. Now we're going to go to the right. And I like to go where I can see that it's above the x-axis. That's me. Hit enter, that guess is fine. What is it, 10.5? Which is what we knew it was to begin with. All right, do you want to know how to change that to a fraction without actually having to type in 10.5? Okay, since I calculated x is equal to 10.5, 10.5 is stored in my calculator for the variable x. That was the last calculation I did. So it is stored in my calculator. So if I exit the graph and I go into my calculator and I say x, get to the x button, and I want to change that to a fraction, math number 1. It will take whatever x is, whatever is stored in there, and change that to a fraction. Anyone has? So whatever calculation you did, whatever value you got for x, at that moment, it is stored in your calculator for x. To recall it, you just need to go in there. You can just type in x and enter, and it will recall whatever that value is. And then you can change that to a fraction, which I did in one step, but you can change that to a fraction. So it's kind of cool. This calculator is cool beans. All right, would you like to know how to do this using the intersection method? The intersection method is nice because you don't have to rewrite the equation. That's what's cool about it. So the intersection method, you're going to put the left-hand side of the equation in y1, and the right-hand side of the equation in Y2. And then you're gonna graph it. Okay, so what was our equation again? Let's write it back up here. So our equation that we started with was 2x minus 3 over 4 equals x over 3 minus plus 1. Okay, so we're gonna put that in Y1 and we're gonna put that in Y2, and then we're gonna graph it. Okay, so I'm gonna clear out what I have in my y equals. I could delete it, but I'm just gonna clear it and start over. Okay, so we have alpha, y equals number 1. We have 2x minus 3 over 4. So there is the left-hand side. And I'm gonna go down to the y2. And I'm gonna type in the right-hand side, and I really don't need to use the fraction. I can just do x divided by 3 plus 1. My calculator understands to take the x, divide it by 3, and then add the 1 to it, and understands that. On the left-hand side, I would have had to put the numerator in parentheses since there are 2 terms. Okay. So then I'm just going to do a zoom standard, zoom 6. And it's outside my window again. The intersection is outside the window. So I'm going to change my window and hopefully it'll work this time. There we go. So I changed my window, the X max to 20, so I could see that intersection. Now, intersection is so much easier to do than 0 because you don't have to, go to the left and to the right and then enter a guess. This is what you do. So again, go to your calculate menu, which is above the trace. And number 5 is intersect. It will find the intersection of any 2 curves you have graphed. So you hit number 5. And what does it ask you? First curve. So it's blinking on your first line. It's going to blink on Y1. You say yes by hitting enter. And what does it do? It jumps to the second curve for you. So what's your second curve? Is that the Y2? The x over 3 plus 1? You hit enter. That is my second curve. Yes, that's fine. 10.5. So the intersection of those 2 lines is the number that satisfies both the left-hand side of the equation and the right-hand side of the equation. So graph one side in Y1, the other side in Y2, where they intersect is the value that will make the left-hand side and the right-hand side the same number. It's like that. I use this all the time. Okay. Let's do it again. Let's use it for this example. Let's use the x-intercept method and the intersection method. In 2017, worldwide digital and spending reached 227 billion, while TV ad spending stood at 178 billion. The upward trend in digital ad spending from 2017 and projected to 2023 can be modeled by the function, and we got it on 2 lines, sorry about that. Y equals 48.953x minus $613.505 billion, where x is the number of years after 2000. Define the year when worldwide digital ad spending is predicted to reach 700 billion. Write an equation and solve it by using the x-intercept method and the intersection method. You should get the same answer. So what are you looking for? You're looking for the year when this equation y equals 48.953x minus 613.505 equals 700 billion. So you're trying to find the intersection of that line y equals whatever with y equals 700 billion. So where does that line cross and touch 700 billion? Now you could certainly plug that in and find the value. You could certainly do that, but we're going to use the calculator. Now, this is going to be one of those where we're going to have to change our window considerably. Maybe at least to see the y values, we're going to have to change it quite a bit. So I'm going to go into my y equals and I'm going to clear out what I got in there. And I probably should go back over here. So what I'm looking for is where y is 700 billion. Okay, so to use the x-intercept method, I need to get that 700 over to the other side. I need 0 on one side and the equation on the other. So I'm going to subtract 700 from both sides. To use the intersect method, you just need to put one in y1 and the other in y2. So what do you get? Is that minus 13.505? Okay, so I'm going to put that in my calculator. Okay, so I had 48.953 x minus 13.505. I don't know why I had that y2, but it doesn't matter, it'll work. I think I'm gonna have to change my window quite a bit. I'm gonna change my x from 0 to 100 and see what that looks like. And maybe change my y from, I mean, it's gonna be doing something like this, but the y-intercept's way down there. But let's just try it, setting the x from 0 to 100 and y will be y alone. So let's go 0 to 100. And I'm just gonna leave y alone and see what that looks like. There you go. So is it crossing right there? I might change my scale to 10. That might look prettier. There you go. So is that 10, 20, somewhere between 20 and 30? Is that where it's crossing? If this is 10, this is 20, this is 30, so maybe 26, 27, somewhere in there. Okay, so how do I find that? Go second, calc. Number 2 is 0. Am I to the left of it? No, I'm to the right of it because I'm at x equals 50 and I need to be there to the right. So I need to be somewhere over. I need to be to the left. I need to be somewhere over here. So I'm just going to move. Will I see that I've moved to the left of that? Should be seeing the cursor pretty clearly. No, I don't know. I never saw the cursor, but I'm to the left of it now. That's 10, 20, 30, right? So I'm gonna hit enter. And then I'm gonna go, there it is. It is to the right. Now I'm gonna go to the, oh, why is that to the right? I need to be to the left. Let me start this over again, folks. Okay, left bound. That's fine. Right down, I need to be to the right, so let me move to the right. There we go, I saw it move, enter, that's a fine guess. 26.831961. And since we started a problem with decimals, am I going to write it in decimals? However many places they tell me to round up to. Okay. That's the intersect, the x-intercept method. The other method is to put the 700 in one of your y equals. And in the other, we're gonna write that equation. What was that? What was it? 613? Okay, and then you're gonna graph that. Looks to be outside my window, so let me change my window. What did I change my window to? The answer here, let me change my Y scale. Let's make that 700. Well, I need to make it more than 700 because I'm looking where it intersects with 700. Let's make that 800. And let's make the scale, I don't know, let's make it 50. There we go. So now can you see where it intersects? The reason I couldn't see that is because my Y window was not large enough to encompass that Y equals 700, which is a horizontal line. So I need to make the window large enough to include that 700. Now you can turn on your trace. You should probably get fairly close by just turning on the trace and going over there. You could do it that way, or you can use intersect. Too far. Okay, so go second, calc number 5. First curve, second curve, yes. 26.831961. Give me answer.
You do the first curve, or could you do the first curve to the right?
Yes.
That doesn't have to be left of the intercept?
No. Okay. If I don't get done, I'll push your homework out. Not too chance about, especially since you have a test. We don't get what's done with T1 today, I'll just push your homework out a week. I'm fine with it. Because I have about 4 more slides and it probably will take a good 15 or 20 minutes to go through these 4 slides. The formula for the future value of an investment of P dollars at simple interest R for T years is A equals P times 1 plus RT. So this is simple interest. P is the amount of money you invest. R is the interest rate you invest at. T is the number of years you make this investment for, or this works with borrowing too. And A is the amount of money you have left, the amount of money you have after T years investing P dollars at an interest rate of R. Can you solve that for R? And the answer is sure. Because A and P and T are numbers. That's all they are. They are numbers. So ignore the fact that they're an A and a P and a T. And they're just numbers. They're just numbers. So if the variable you're solving for is inside parentheses, what do you have to do? Just doing this. You have to get rid of the parentheses. You have to distribute across, correct? So if R is inside parentheses, do I need to get rid of the parentheses? Yes. So how do I do that? I need a pencil. Distribute the P across. So I have P times 1. And I have P times RT. So I took the P times the 1. P, then I took the P times the RT. PRT. And then hit it with my finger and made it. Okay, now, the variable you're solving for is R. So A and P are numbers. So if the variable you're solving for is R, what do you need to get rid of on the right-hand side of the equation? Everything but the R. So what do you want to get rid of first? The P. So if I subtract P from both sides, that will isolate the term that contains the variable I'm solving for, the R. So how do I get rid of the P? Subtract it. So if I move the P and it's positive on the right-hand side, if I move it to the left-hand side, what sign does it become? Negative. So if I subtract P from both sides, do I end up with A minus P over here? You're solving for R. You gotta get rid of everything but the R. So what do you gotta get rid of? The P and the T. How do you get rid of it? Divide. If P and R and T are being multiplied, how do you undo a division? How do you undo a multiplication? You divide. So what do I divide by? And the P, T, and A are numbers. They are just numbers, like 2 or 3 or 5 or 10. They're just numbers. So can I divide by them? Sure. Why not? So what's my answer?
A over P is R. This way the P and the T cancel out.
T, not just a P.
3 minutes. That's a great question. The P, does the P cancel? Why not?
It's multiplied by T, so that's not gonna be what the actual number is.
That's true.
It wouldn't make sense. I mean, when you get your final answer, if you cancel out the P, it's not gonna make sense.
That doesn't make any sense. Where does the P go? Where does your principal go? It has to be in there. That's a really good point. Did you hear what he said? What a great point that is. I'm gonna remember that, steal that forever. If the P goes away, how do you calculate if you don't know what the principal is? You don't know how much you invested. If you know how much you have when you're done, but you don't know how much you began with, does that make any sense at all? The reason you can't cancel it is because it's not a factor in both terms in the numerator. You would have to have a P over here next to the A to be able to cancel it. It has to be able to be factored out for you to be able to cancel it. Right, so I didn't get done. So what's that mean for you? I will push the 2.1 homework out. It would normally be due the 11th, correct? I will push it out to the 18th. But I go ahead and get started on it if I wait. All right, any questions? All right, have a great rest of your week, everybody. I'm gonna try and progress. I have answers, but